So if you have an example here, calculate the SAR of the soil if the calcium, magnesium, sodium, potassium, chloride is these values. To calculate the SAR, you will not use potassium and chloride. You will use only the three element and use this equation, and you will obtain 5 SAR. 5 means that the soil is non-sodic because more than 13 is considered sodic, while less than 13 is considered non-sodic soil. The soil have SAR value of 13 or more may be characterized by an increased dispersion of organic matter and clay particles. Consequently, this will lead you to the reduce of saturated hydraulic conductivity and irrigation. Sorry, and in a general dispersion of structure or soil structure. This shape show you a sodic soil. To reclaim the sodic soil, you have to add a gypsum. A gypsum is a source of calcium, and the calcium replaced the sodium on the soil particle and caused coagulation and improve the aeration and other physical properties of the soil, physical and chemical properties of the soil. So the gypsum is to solve the problem of sodic soil or sodicity. This table summarizes the previous explanation. If the soil is less than, if the electric conductivity is less than 4, the soil is in non-saline soil, and this non-saline soil has the SAR less than 13 and ASB below 15. The physical properties here is fluctuated. Saline, the EC more above 4, while SAR below 13 and ESB below 15. The saline soil is fluctuated. Sodic soil, the EC is not a saline soil, by the way. The sodic soil is not a saline soil because it's usually it's EC less than 4. However, the SAR above 13 and ESB more than 15 dispersed. Here, the problem is that the sodium is dominant on the exchangeable side of the clay particle. So make dispersion to the clay particle. You have to add gypsum to reclaim this soil. Saline sodic soil, both. The electrical conductivity is above, and all ESB and SCR above 13 and ESB above 15. Consequently, this soil is fluctuated. So this table summarizes the previous. This diagram also, here the EC, previously the EC unit is DC Siemens per meter or millimoles per meter. This diagram uses another unit for EC called micromoles per centimeter. This equal DC Siemens multiply 1000, DC Siemens per meter multiply 1000, or millimoles per centimeter multiply 1000. You will get here 400 micromoles per centimeter equal 4 millimoles per centimeter. Okay, 8000 mean 8, here it mean 12, ESB 0, 15, 30. We are now, if more than 15, it can consider sodic. So if the soil is less than 4 or 4000 micro and less 15, the soil is normal and non-sodic or non-saline. If the salinity is more than 4, it can, and ESB less then 15 the soil is saline. Here is the soil is AC is less, however ASB is more. Then here is sodic, while here is saline sodic soil. Here is general limit for most plant. Here suggest for the salt suggest value for salt sensitive plant. Okay. Here increased salt hazards. Here increase sodic hazards. Sensitive plant can be planted here, and here should be plant salt tolerant crop. Salt tolerant crops. Reclamation method of saline soil. You need to remove the salt from the soil. So the only way to remove the salt from the soil is to use a good irrigation water quality, has a EC is less than 4, and construct a good drainage system to leach the salt away from the soil profile. Leaching the salt from the soil by good quality water as works to dissolve the salt, the water dissolve the salt from the soil and remove from the root zone. The salt concentration of the soil should be reduced at a depth of 45 to 60 centimeter. Disruption of reclamation. If there is no poor drainage, poor hydraulic conductivity of the soil, poor drainage, you have to construct a good drainage system to remove the salt. Poor hydraulic conductivity, add gypsum to improve aggregation. Prevent presence of hard pan. So you have to look for a solution to overcome this problem by deep plowing or whatever. You have to use a good water for salt water reclamation. Sodic soil is defined as the soil where the percentage of exchangeable sodium, as I told you, is higher than 15, while the AC is less than 4. Sodium absorption is more than 13, and its pH consequently, because there is a sodium, the pH is more than 8.5. High concentration of sodium and low concentration of salt in the soil lead to this is the problem. The dispersion of the particle in subsurface layer, and the permeability becomes low and the structure destroyed. So the pH range between 8.5 to 10 due to hydrolysis of sodium carbonate. Sodic soil, called black alkali soil, due to solubilization of sodium humate that deposited on the soil surface in the form of black spots, like this photo. How to reclaim sodic soil? The first step to add gypsum. You must first replace cations with exchangeable sodium, and then you use another cations like calcium instead of sodium in the exchangeable complex, and leach the sodium away from the root zone. In most cases, calcium is used to replace sodium in the sodic soil. Calcium sulfate, gypsum, is the best and cheapest material to meet their purposes. calcium replaces sodium and aggregation is conducted. You may add sulfur, and Cyanobacillus bacteria can oxidize sulfur to sulfuric acid, and then sulfuric can react with, especially you can add sulfur in calcareous soil. The sulfuric acid can, the Cyanobacillus bacteria are slowly oxidize the sulfur to sulfuric acid, and then the sulfuric acid can react with the calcium carbonate and produce gypsum as a source of calcium and solve the problem. On saline sodic soil reclamation, the first you can all are high EC, SAR, and ESB. However, due to salinity, the pH is less than 8.5. The particle is fluctuated at beginning, but when you remove salt, the soil disperses. So how reclaim this soil? To reclaim this soil, the first step is remove salt by using fresh water and good drainage system, and then put gypsum later after removing salt. Because in this soil, first you will find the soil has a good aggregation, and while when you start removing, you will observe that the soil begin to disperse, and the water cannot infiltrate to the soil profile. In that case, you have to add gypsum to remove sodium from the exchangeable site and re-aggregate the particle, and then you can solve the problem of sodicity and salinity. Reclamation efficiency of salt affected soil. The efficiency of reclamation depends on several factors. The first is soil texture, the drainage, good drainage, quality of irrigation water, sufficient source of dissolved calcium and magnesium, addition rate of gypsum, and addition method, climate conditions. So the soil texture, the coarse texture is easier for salinity removal than fine texture. Drainage system, good drainage system is important for removal salt and sodium. Quality of you should use good quality of irrigation water. Sufficient source of gypsum. The climate condition, if there is a hot climate condition, then you have to irrigate in shorter intervals. Add more water. As you know, the sodicity causes dispersion while and affect on permeability and hydraulic conductivity of the soil, and the rate of vertical water movement within the soil profile decreases due to the swelling and dispersion of clay granules. So this is the problem of sodicity. However, salinity causes osmotic pressure to increase, and the plant may be wilted due to its ability to absorb water decrease. The increase of ESB higher than 15 led to the expansion of montmorillonite mineral due to the absorption of large amount of water in these type of. Salinity and sodicity plant growth. Salinity and sodicity significantly affect plant growth. Sodicity can cause plant toxicity because sodium may be toxic to the plant, as well as calcium deficiency because there is a competition between sodium and calcium, and due to the higher concentration of calcium and low concentration high concentration of sodium and low concentration of calcium, the sodium be dominant and the calcium deficiency occurs.